Welcome to another episode of Fresh Thinking by Snowden Optiro. My name's Jan Graham. I'm a Principal Consultant with Snowden Optiro based in Perth, Western Australia. This is one of a series of podcasts focusing on specific commodities and the issues associated with mineral resource estimates for that commodity. Today we're talking about nickel sulfide deposits. I'm here with Ian Glacken, who's an Executive Consultant from Snowden Optiro, based here in Perth too. Welcome, Ian.
Thanks, Jan. Good to be here.
So, Ian, today we're talking about the issues around the estimation of nickel sulfide deposits. What is your experience and what are you qualified to talk about this subject?
Okay, so I guess you could say that in terms of geology or resource estimation, nickel sulfide was my first love. When I graduated from university way back in the last millennium, I came out to Australia and the first place I worked was at Kambalda in Western Australia. And Kambalda, at that point, the company there was Western Mining, WMC, which some people may have heard of. And they had two major commodities there. One was nickel sulfide. Komati hosted nickel sulfide, and the other one was gold. So the first 4 or 5 years of my career as an exploration geologist and a mine geologist was spent working in Komati hosted nickel sulfide deposits.
Sounds like solid experience.
Yeah, hope so.
So what are the key types of nickel sulfide deposits with respect to estimation?
Okay, well, we could really, at the risk of grossly simplifying it, we could really just talk about two styles. One is the more structurally hosted, perhaps more concentrated sulfide, of which the Kambalda deposits, that's the Komati hosted nickel sulfide deposits, are an example. We also have the deposits in Sudbury in Canada, Thompson, Manitoba, and lots of other styles of nickel sulfide deposits of a more concentrated nature in Western Australia and elsewhere. So that's one style. The other broad style, which we would maybe treat differently from an estimation point of view, is disseminated peridotite or dunite hosted nickel sulfide deposits.
Okay. Well, let's start with the more structurally hosted deposits, the Kambalda style. So what are the estimation issues associated with those?
I think with any estimation, and nickel sulfide is no exception, one of the keys is the domaining. And it's all about getting the domaining right. So if we talk about the classic Kambalda style, which is hosted in ultramafics, they're structurally controlled with either faults or pinch outs on either side of the Komati hosted channels, then the key is to get the domains right. Typically, we would domain it on the basis of structural boundaries, so faults or folds or whatever. And then within that, we would look at the style of the sulfides. And we would have a distribution of sulfides from disseminated 5 to 10% up to massive, which would be more than 80%. And typically when we were doing the domains, we would split those up on the basis of the sulfide percentage or proportion. So we'd have massive sulfides, matrix sulfide, disseminated sulfides, and so on. And when we get to the disseminated sulfides, we might use a lower cutoff grade. So really, it's all about the structural setting, and it's about the nature of the mineralization. And if we have brecciated or a disseminated material, then we would separate that out. We'd separate that out as well. So in terms of the modelling, the shape of the domains is important, and the Kambalda style or other concentrated nickel sulfides, they tend to be quite undulating, folded sometimes grossly folded, and depicting the style of folding or the nature of the domains is important, and this is where techniques like dynamic anisotropy is important. Dynamic anisotropy is where we orient the search ellipse in the plane of the mineralization, and there's quite a few techniques for doing that. So that's important because of the shape and the style of the distribution. So it's important to get the domains right. It's important to estimate them correctly using the right constraints. The actual grade estimation technique is not particularly significant. Typically, we would use normal, ordinary kriging or something like that. But it's really all about getting the domaining right. Okay,
sounds good. I understand sometimes people use 2D modelling or C modelling. Can you tell us more about that?
Yeah, sure, yes. That's very prevalent in nickel sulfides. And the idea of a C modelling is where we have an ore body, typically a nickel sulfide ore body, a massive sulfide zone or some remobilized sulfide, which is It's undulating and it changes in both orientation and thickness. And one of the issues with that is sometimes it's quite narrow. And if we were to generate a traditional block model with cells and subcells, then we might find that to represent the volume of the mineralization, the cells and the subcells would need to be so voluminous that the model would be unwieldy, and we'd have very large models, and we wouldn't represent the volume very well. So one of the techniques is to use 2.5D or seam modeling, which is where we composite the drill holes over the width of the ore body. Now, one of the key assumptions here is that we're going to mine the entire ore body, because once we've composited the drill holes over the ore body, we've got no opportunity for selectivity, right? Yep. Because we can't be selective. So we need to be happy right at the start that we're going to mine the entire seam. And of course, if we're dealing with massive nickel sulfides, then that's something we are going to do. We're going to mine the whole lot. So once we've made that decision and we've composited over the width of the ore body, then we create a variable which we call an accumulation. Accumulation is simply the width times the grade. Now, the way that works, of course, is that we need to estimate the width times the grade, which is the accumulation. We also need to estimate the width or the thickness, and we need to divide one by the other. And this allows us to have much larger cells. It allows us to composite over the width of the ore body, and it makes our models much more easier to deal with. Now, one of the quirks of nickel sulfide, and those of you that have worked in nickel sulfide, you'll know that it's one of the few commodities where we have a correlation between the grade and the density. The higher grade is almost always the highest density. And that means that when we're generating composites, whether they're regular composites or whether they're seam composites, we need to weight by the density. So one of the twists on the accumulation technique is to weight not by length, not just by length, but also by density. And this is sometimes called a triple accumulation, at the risk of getting quite complicated. But we do need to cater for or cope with this relationship between grade and density, which as I said, is very peculiar to nickel sulfide deposits.
Sounds good. I know you're involved with the Nova Bollinger deposit. Did you use accumulation there or 2D modelling?
Yeah, so Optiro and Snowden Optiro, this was many years ago now, but we were involved with the first few estimates of Nova Bollinger with Sirius Minerals, and later on to a lesser extent with IGO. That's a very complicated nickel sulfide deposit, and the key issues there with the domaining was to understand the nature of the mineralization, whether it was brecciated, massive, and also to understand the relationship between the mineralization and the host rocks, gabbro or things like that. And the other thing we did in the initial estimate there, or the initial estimates, was actually unfolding. We used data mine unfolding, which is quite a complicated technique, but in this case it worked quite well. So that was quite a interesting exercise, which involved quite a few techniques. But essentially we were looking at the structures and the textures of the mineralization.
Okay, so let's think about the more disseminated style of mineralization of nickel sulfide. What are the key estimation issues with that?
Right. Obviously in this case we're talking about bulk mining of quite low grade disseminated sulfide deposits. So the key issues really is the mineralogy, the specific mineralogy of the nickel, and the metallurgy. When it comes to mineralogy, we need to, particularly with low grade, we need to think about the relative proportions of the key minerals. So that, with nickel sulfide deposits, the key minerals are pentlandite, pyrrhotite, which contains some nickel, but also then we tend to have some more exotic species like violarite or other minerals like that. So it's important to understand the relative distributions of the various sulfides. The other issue is that sometimes we have some species like violarite where the recovery is less. So it's important to understand the relationships of the various sulfides. The other issue, and particularly this is the case with disseminated nickel sulfides, is the proportion of what we call sulfide nickel. In other words, nickel that's contained in sulfides versus nickel that's encapsulated in silicate minerals. And the silicate nickel, or the non-sulfide nickel as it's known, is much harder to extract. So we do need to know that relationship between the sulfide nickel and the non-sulfide nickel. So that's one issue. The other issue is this idea of geometallurgy, which is related to this sulfides versus non-sulfide, and it's important to try and model the proportions and relative concentrations of the contaminants. So one of the key contaminants from a lot of nickel sulfides, and this applies to more massive deposits, also to disseminated deposits, one of the key contaminants would be arsenic. So we need to model arsenic, because arsenic, unfortunately, has concentrations that can go from the single ppm up to the thousands of ppm, and arsenic will impact on the quality of the concentrate that comes out of it. And this applies to massive or to disseminated deposits. So from a geometallurgical point of view, the presence of these contaminants like arsenic, it's very important. So I would say that the estimation side of things is fairly straightforward. The key is the cutoff grade, the proportions of the minerals, and the geometallurgical variables, particularly to do with things like recovery.
Yeah, it sounds like the geomet's very important. Is it common for nickel sulfide mines to have a geometallurgical model?
It's increasingly common, has been for quite a while. I mean, we did some work on a project last year which was all about the geometallurgy. One of the projects I was involved with many years ago now was the Mount Keith deposit, which is now owned by BHP Nickel West, but in those days was owned by Western Mining. And we generated one of the first geometallurgical models at Mount Keith, and we had a whole heap of metallurgical tests, recovery tests, and we were able to interpolate those in 3D, and we were able to generate a model of the process recovery, not just the nickel grade, but the actual recovery. And then the mining engineers were able to schedule on the basis of recovery rather than the actual nickel grade itself, because the grade wasn't the important thing as much as the proportions of nickel and the minerals it was contained in, and also the contaminants. So this idea of a recovery model is fairly common these days, and certainly if we're dealing with disseminated nickel sulfides, it's almost de rigueur to generate a geometallurgical model.
Thanks, Ian. Okay, so that brings us to the end of our podcast on nickel sulfides. Many thanks, Ian, for giving us your views and sharing your experience with us on the topic.
Thanks, Jan.
If you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you'll find them on our website, on Spotify, Apple Podcasts, Google Podcasts, YouTube, or most other podcast platforms. Thank you for joining us. If you enjoyed this podcast, please subscribe.